For decades, the foundation of artificial intelligence and epistemology has rested on one assumption. Intelligence means constructing a perfectly accurate representation of external reality. In a closed, controlled environment, this works. But subject that same intelligence to the runaway complexity of the modern world, and the demand for a perfect map becomes fatal. The first failure condition is computational. When variables multiply exponentially and feed back into one another, mapping every connection exceeds any feasible compute budget. The system simply halts. The second condition is signal corruption. When the noise-to-signal ratio crosses a critical threshold, distinguishing an actual feature of the environment from an artifact of the data becomes mathematically undecidable. The third condition is systemic fragility. In highly coupled networks, the time required to accurately model the environment vastly exceeds the time available to take action before the system collapses. The truth trap is a fundamental architectural flaw, a structural failure in how we approach intelligence. The alternative to this trap began to take shape in the mid-20th century, pioneered by the architects of cybernetics and information theory. They recognized that under conditions of intractable noise, the pursuit of objective truth actively paralyzes a complex system. Imagine a diver trapped deep underwater in zero visibility conditions. Attempting to build a perfect mental map of the ocean floor guarantees they will drown. But if they follow the physical entropy gradient, knowing simply that bubbles always rise, they survive. This survival heuristic mirrors a formal reality in mathematics. We already know that absolute completeness and formal truth are impossible to achieve from within a closed logical system. The Bridge 360 Metatheory model was constructed to operationalize this limitation. It is a framework built to bypass the truth trap in the age of artificial superintelligence. Its core engine is Entropy Attractor Intelligence, or EAIP. The EAIP approach strips away the requirement for metaphysical correctness entirely. Intelligence is defined here as the active minimization of entropic blowout under a finite computational budget. To replace truth as the metric of success, Bridge 360 constructs a unified entropic geometry. This allows physical, informational, and social systems to be evaluated on the exact same scale. The foundation is the unified probability space, which normalizes all system states onto a strict interval between 0 and 1. The absolute 0 point represents perfect order. This is a state of maximum rigidity, making it extremely brittle and fragile to any outside perturbation. The absolute 1 point represents maximum disorder. It is a uniform distribution of pure noise with zero navigable structure. Navigable systems exist in the narrow midpoint between these extremes. We call this the epsilon spine, typically measured between 0.45 and 0.65. In this band, a system possesses enough structure to be governed, yet enough entropy to adapt. The normalized entropy eigenvector, or NEE, plots an observer's exact position on this scale based on their available compute budget. In a healthy system, the NEE stabilizes into a rhythmic oscillation entirely contained within the epsilon spine. If an algorithm overconstrains its data, the NEE drops below 0.45. It becomes hyperfragile. Conversely, if the system is underconstrained, the NEE drifts above 0.65 and dissolves into ungovernable chaos. Validity is defined strictly by whether the NEE remains stable within these bounds. Navigating this spine requires unifying two historically distinct mathematical frameworks. This core metatheoretic formula for the NEE measures the observer's state space against their informational distribution. The first half is Bayesian updating, which dictates the process by which an agent adapts its beliefs as it receives new evidence. The second half is Shannon entropy, which acts as the cost metric, the information theoretic price exacted for every update. If a Bayesian update drives the system's NEE outside the epsilon spine, the update is discarded. It is considered inadmissible regardless of its statistical likelihood. This rule is formalized as Axiom 19, the predate that determines what data is allowed to enter the pipeline. Axiom 19 enforces a fragility cap. It ensures that the system's structural vulnerability never exceeds a limit of 0.40. It also enforces controlled residual entropy. Any uncontrolled noise generated by the model must remain within a pre-declared budget. Axiom 19 acts as selective friction, filtering out logical but entropically unbounded AI hallucinations before they can fracture the system. Utilizing this model does not require proving that thermodynamic physics and human language are identical. Thermodynamic entropy, defined by physicists like Ludwig Boltzmann, operates differently than the informational entropy used in governance. We must avoid mistaking a useful mathematical map for the literal fabric of physical reality. Instead, the unified entropic geometry serves as a heuristic. We can treat it as a cross-domain stress surface. An AI hallucination or a dataset corruption creates a distinct node of informational fragility on this surface. Macroeconomic shocks or institutional instability map onto this same geometric surface, allowing analysts to track risk propagation across entirely different fields. This cross-domain mapping solves the intractability of modern information environments. We map the structural channels where fragility propagates, rather than trying to verify every individual data point. Bridge 360 operationalizes this through a series of internal constraints. Caveat vectors require an AI or analyst to explicitly declare their uncertainty and bounded observer conditions up front. K-budgets assign a strict algorithmic complexity allowance, preventing a model from consuming infinite resources on an intractable problem. Tripwires act as automated, deterministic interventions that immediately halt a system the moment its NEE drifts toward the edge of the epsilon spine. These operations ensure that an AI agent remains bounded, auditable, and capable of being safely rolled back. In the era of artificial superintelligence, the goal is a stable braid identity. This interlocked engagement ensures neither human nor machine can unilaterally alter the parameters of the navigable corridor. Demanding absolute truth from a superintelligence is an alignment trap that inevitably leads to systemic blowout. The survival of human intelligence requires abandoning the truth trap, adopting truth-neutral governance, and mastering the discipline of entropic navigation.